Good morning, good afternoon, and good evening from wherever you're joining us. This is Cloud on Air, the journey from big data to AI. I'm Laith Masarwe, the global marketing lead for media and entertainment for Google Cloud. And today, we'll be talking about machine learning and its applications in the media and entertainment space. We have Googlers standing by to take your questions, so if you have any thoughts or comments or questions, please feel free to include that in the chat box. So if you've been following the space, you may have heard something about machine learning. But with any nascent technology, there's always the risk of overhyping or misunderstanding what it is and what it can do. So today, we'll talk about what machine learning is, how can you use it tangibly in media and entertainment today, and talk to you a little bit about where we're going with it at Google. So I got my start in media and entertainment at a film production studio, and I started out on the content side. And in Los Angeles and in the creative community, there's a very overused, if somewhat accurate phrase attributed to William Goldman, the screenwriter of such classics as The Princess Bride, All the President's Men, and Butch Cassidy and the Sundance Kid. So he kind of knows what he's talking about. And what William Goldman said is that nobody knows anything in this town. And what he was referring to was the fact that some movies that seemed like a slam dunk, great director, great actors, pre-existing IP, oftentimes fail, whereas others come out of nowhere to be huge successes. And that's commonly accepted in the creative community. There is an alchemy to making a movie or making a TV show or a great video game that can't be quantified with data. So when we think about machine learning, which is very much about using data to make predictions and solve real-world problems, how can these two left side of the brain and right side of the brain kind of come together to create value for media companies? Because, as we all know, storytelling can take many different forms, from verbal storytelling to the written word, to filmed camera, and even to VR and AR. So between the creation of content and the creative side and the inspirational piece of media versus the technology and the tools that are used to create that media, there's an interplay there. And this is Van Gogh's Starry Night, which we can all agree is a work of art and a masterpiece. Can a machine produce something that is this beautiful and this original? You may say no. Excuse me, you may say no. But some researchers in Germany actually used machine learning algorithms to take Van Gogh and apply his style to a random picture of a neighborhood somewhere in Germany. And you can see the effects of their innovative work here. Now, we can debate the artistic value of these pictures, but what is not debatable is that these researchers took machine learning as a tool to create something new. And that is really the original piece and the inspirational piece where that creative element and the technical element come together to produce content. But there are opportunities beyond content creation for media companies who are looking to get into ML. And we think about it in three distinct buckets. One is the content itself. Two is how do you use ML to help engage that content with your desired audience on a global scale? And then three is how can you use machine learning to help your company become more agile and more efficient so that you're spending time on the strategic problems and not on manual workloads that may be very time intensive. But before we get into those practical applications, let's take a minute to think about what is machine learning. So machine learning is a branch of the larger field known as artificial intelligence. There's a tendency to conflate the two, but machine learning is really its own thing. And you may have heard the term deep networks or neural networks or deep learning. That refers to a branch of machine learning that is taken basically the way that humans process information from a biological level in terms of how our brain processes info, and use that as inspiration for machine learning algorithms and models that can learn rather than are explicitly programmed to do a certain outcome. So you can imagine if you have a problem that you want to solve, you can write thousands of if-then rules, but that application will be pretty limited. Whereas machine learning algorithms, they learn by learning. So they can solve all types of problems without being explicitly programmed to do so. So what are the keys to successful machine learning implementation? That really comes in three forms. One is a good model. Two is a large amount of compute. And then three, and probably most importantly, is access to large quantities of quality data sets so that you can train those models. So let's talk about those a little bit more. First, as I mentioned, is building a model. So deep learning is a term that you may have heard, and that's basically a class of machine learning that has gotten a lot of well-deserved attention in recent years because it can solve a variety of AI problems in vision, natural language processing, and many others. Also, in contrast to many of the other machine learning algorithms where data scientists or software engineers have to figure out which features will lead to good predictions, deep learning approaches figure out those features for themselves. And as I mentioned, it's inspired by the way that the human brain works. So if you see on this picture, there are various input layers and various nodes. You may hear nodes referred to as neurons because our deep brain team really wanted to simulate how the human brain processes visual information and speech information, but using mathematics to apply that to algorithms. So what will happen is when we feed an input into the system will continue to basically take the same test over and over again and say, is this a dog or is this a cat? And if you've ever taken a multiple choice quiz where you just go through it and take it again and again and again until you do it right, that is essentially what the machine learning algorithm and model is doing here. So every time it goes through that one process, it gets better at predicting, is this a dog or is this a cat? So these models have theoretically been around for many years, but why we've seen a recent kind of uptake in machine learning is due to the availability of cheap compute, which is generally attributed to how GPUs work. So GPUs previously, before machine learning, were used to figure out computer graphics, gaming rendering, and shading pixels on special effects. And the researchers realized that the type of computation that GPUs use is actually very, very applicable and very similar to the type of computation that these machine learning algorithms need. So the availability of GPUs has really kind of spurred and opened up the floodgates for many people to experiment with deep learning algorithms. And at Google, we're taking that one step further by introducing TPUs, or tensor processing units, which are custom built to handle deep learning and machine learning training workloads. And then the third piece of getting to ML is data. So the large availability of data today on the internet is a huge problem for companies that are trying to wrestle with how can I take these large amounts of data and make it usable towards a certain business problem. And if you think about from a video perspective, there are over 400 hours of video uploaded to YouTube every minute. The average American watches 5 hours of TV a day. And in the next couple of years, video traffic will actually account for about 80% of all internet traffic. So there are huge amounts of data, both video, but also text and speech, that is out there and being produced by media companies. And the first step to machine learning and AI is learning to harness that data and put it to use in a very, very specific way. So on a theoretical level, that's basically how machine learning works. You have a model, you have compute to run and train those models, and you need data, which is the rocket fuel that kind of makes machine learning go. But the theory is all well and good. How can you apply this technology and these tactics to solve real business problems that you have? And because machine learning has such a wide array of applications, what we've seen from people that we work with is we really want to hone in on what is the specific business problem that you're trying to solve. That could be a much harder question than figuring out how to set up your model and which data sets you get. Don't get me wrong, those are still important problems. But when it comes to planning, it really starts with that business problem. So once you've identified that problem, how can you develop a hypothesis that says, these are the range of potential solutions? Once you've taken those two kind of steps in terms of outlining what you want to do, then you need to find the accurate data, the quality of data, and the quantity of data that can help you solve that problem. Once you have that data, you can build the model, train the model using that data, and then apply it wherever you may have an app or a game or a video, whatever you're trying to accomplish, you can apply machine learning to help solve those problems. And that's what we're doing at Google. So machine learning is truly a transformational aspect of what we are bringing to Google, what we're bringing at Google, and how we build our products. we're rethinking how all of our products can integrate machine learning so that they can be much more useful for our consumer products, whether that's Gmail, YouTube, Search, Android, Maps. All of these products are utilizing machine learning today so that we can deliver a better customer experience to our users. And you see this graph on the lower right-hand section here, which is the amount of machine learning libraries that we've used at Google. And if you recall that slide in the first, that graph in the first slide, we are clearly on the uptake and we are clearly on the early side of machine learning. But unlike that slide, we don't think that we will go through the trough of disillusionment, if you will. We only think that we will continue to build, to utilize machine learning in everything that we build so that we can deliver that end user happiness. But we're not stopping there. At Google Cloud, we want to bring those tools and learnings to you. So we have a comprehensive suite of AI and ML offerings. Over on the left, we have a range of pre-trained models that you can access via API. Or on the right, you can use your own model, you can write your own models using TensorFlow, our open source ML library. If you prefer other libraries, you can utilize those as well and use GCP to help run them and train them. So we also have a variety of professional services because we don't want to just hand you an API or a tool and tell you to, and have you kind of run off. We are here as thought partners and trainers and experts to help you along your ML journey. So we have various training programs that you can check out on the Google Cloud website. No matter if you're a 2-person company or a 2,000-person company, we want to meet you where you are on your ML journey and help you get started there. But more specifically, how can media companies utilize these APIs and tools today? That's what we'll talk about in the next section. So we have a variety of pre-trained APIs, as I mentioned, and the first one that seems a natural place to start is with the speech API. Storytelling has always been a verbal medium ever since its inception. And with the speech API, you have the ability to recognize speech and transcript it into audio. So if you're trying to reach a global audience, for example, and you have a video, you can take the speech in that video, transcript it to text in over 80 languages. And since this is an interactive demo, we have a very, very easy, kind of quick demo for you on the speech API. So I'm actually from Jordan, and the speech API recognizes Arabic as one of its 80 languages. So we can start now. Assalamu alaikum. You can see that it perfectly transcribes Arabic or English, depending on the language that you are trying to reach for the audience. So speech API is very, very interesting usage of machine learning. But once you've transcribed that speech into text, and the speech API also has applications in closed captioning and transcribing news interviews, for example, the next step is translation. So you might transcribe in one language, but then you can translate into many. So our translation API actually understands over 100+ languages and provides very, very high quality translations for you to utilize in your app or throughout your business. For example, one potential application of the translation API is within live chat or a call center analysis. So if you have many people from across the globe who are interacting with your game in various languages, you can use the translation API to really get gamer engagement and have them engage each other, whether they're from Japan or China or France or the US. And one question we always get is, how accurate is the translation API? And I think that's where we're on this kind of early stage of machine learning progress. If you see here in the blue, phrase-based or rules-based translation methods get you pretty far up on the translation quality accuracy scale, depending on the language that you're transcribing or translating, excuse me. With neural networks and with machine learning APIs, you can get much, much closer to the human level of translation. So again, machines are starting to understand the ways that content is being communicated, whether it's verbal, or vision, or video, and we're constantly improving that translation accuracy. Vice is one of the publishers that we work with that use the translation API. As you can imagine, as a global media company, they publish many articles throughout the globe. And their chief product officer likes to say that they have now become octolingual by using the translation API. So this is one example of how a media company, in this case a kind of publisher, is using the translation API to reach a global audience. So speech and translation are interesting because they take speech and kind of convert it into text. And that on its own is valuable, but to me, the natural language API takes that to another step, to another level, by incorporating meaning. So you can transcribe, but humans speak in a very particular way, and the natural language API is a way to add meaning to those transcriptions. So with the natural language API, you can undergo sentiment analysis and understand how your users are interacting with some of your content. For example, if you're a film studio and you have a blockbuster release scheduled for next year, you can monitor the social media presence of your audience and how they're responding to trailers, and use that information to kind of course correct or double down on what's working. The other application of the natural language API is entity identification. So if I say Laith Masarwe works at Google, the natural language API can really zone in on the important parts of that piece of text and say, Google is an organization and it has all this metadata attached to it. And Laith Masarwe, who is not an organization, but rather a kind of individual, may not have as much metadata associated with that. So you can identify those objects within the text and then decipher the meaning of that text. And just to go back to the natural language API, one also interesting application of it is, for example, call center analysis. If you are a telco or an MVPD, you can utilize the natural language API to identify sentiment and find which parts of your customer call centers may not be performing to the standard that you would like. And by honing in on those, you can identify training programs or institute all sorts of techniques to actually improve that customer service. So we've talked about the verbal APIs, as I like to refer to them, and now we're proceeding to the visual APIs. So the Cloud Vision API is a very, very interesting API that has multitude of use cases. It can recognize faces, landmarks, and emotions. It can identify logos within pictures, and it can actually extract text from photos in over 10 languages. So the Vision API is helpful in localizing content. For example, if you have a photo that has some questionable content or content that might be appropriate for certain regions, the Vision API can highlight that for you and stop you before and identify it for you and help you kind of not put it in that compromising position. One particularly interesting use case that we've seen of the Vision API, and this is a very, very nascent one, is recognizing legal contracts from PDFs. So for example, you may have a video that you might not have the rights to distribute in various regions. Extracting that information from those contracts on a PDF can often be challenging. But with the Vision API, it's possible to eliminate a lot of the manual effort that would go into that. And the Vision API accuracy is actually very, very high. So machines can now see like humans. This is some old data, as you can see, from 2015, so we're constantly getting better at it. But in terms of identifying images at scale, the Vision API may actually be even better than or comparable to what a human can do. So in terms of recognizing pictures, the Vision API is actually quite advanced. And that brings me to the final API and my favorite API, which is the Video Intelligence API. It's one thing to understand text or speech or even static photos, but sight, sound, and motion in video is, to me, a completely different ballgame. And as a former film person, to me, it's very, very close to my heart. So a lot of the things that are in the Vision APIs are also in the Video Intelligence API. It can detect objects such as dogs or humans in the video. It can detect faces and actors. It can even detect when editors are making shot changes within the video on a very, very accurate level. But it can also identify events that are happening in that video with pretty good accuracy. So if you're watching a sporting event, You might see goals or a three-pointer. The Video Intelligence API has the ability to identify those events and really zone in on them to create which you can use to create personalized experiences for your users. So if I want to see every three-pointer by Steph Curry, it's possible to take all of the Warriors games and then edit that just to show those those three-pointers to me personally. And the applications of the Video Intelligence API for large media companies is actually quite transformative when you combine it with the rest of Google Cloud Platform's services. So for example, if you are a media company that has large amounts of historical video sitting in a basement on tape, you can take those tapes, digitize them, store them on Google Cloud Storage, run them through the various APIs that we have, and attach metadata to it so that your entire video library is now searchable. And if we go to the demo, we can provide a very, very quick overview of what that would look like. So this is a Video Intelligence API, and we can take a video that is, I believe, a Google commercial set in Rio, and you can see once we run it through the API, it can identify all sorts of elements within that video, such as skyscrapers, crowds, even kind of coasts. So if you're an editor and you're looking for specific clips within this large library of content, you can utilize the Video Intelligence API to very, very quickly grab those and go. So if we go back to William Goldman's quote of "nobody knows anything," it's not quite as true as it used to be. There's still the magical element of content creation and bringing that kind of inspiration to life. But now we have the tools to codify and provide a taxonomy for how is that content interacting in the real world once it's produced. And once you have that data set up, you can start to derive all sorts of interesting insights on how your audience is interacting, how is it monetizing, what do people like versus not like, which can then inform your further content creation initiatives. So it's never going to be a panacea, but more information is always helpful, and these APIs are a great way of attaching that data to your various content. So where are we going, and how can we improve ML to be even more useful? This is a very nascent area that Google is working in called AutoML, or learning to learn. So if you recall on the deep learning slide that I talked about, data scientists and researchers actually have to do a lot of thinking about how do they set up their models. There may be large amounts of layers in a model. You might have a huge model versus a small model, so there's a lot of kind of thought that needs to go into that model. What AutoML does is that it uses machine learning to figure out what is the best model to run based on the problem that I'm trying to solve. So we're in the very early stages here, but the progress has been quite encouraging. So on this slide, you can see that the yellow line is where we were before AutoML, and the blue line is where we are kind of today with AutoML. So there's an incredible amount of improvement even with small model sizes in terms of accuracy if you apply AutoML to your machine learning algorithms. And an important thing to remember is while we're building all of these technologies and APIs for you to utilize, we're not just a tech provider. We are here to partner with you on your journey to ML. And we have a variety of trainings, programs, and solutions where you can interact with Google engineers who will meet you where you are within your cloud journey. Whether you're a 2-person company or a 2,000-person company, we believe that we have the right fit for you that we can partner with. And so thank you for listening to this session about media and ML, and please stay tuned for more Cloud on Air.
And welcome back to everyone from the Industry Solutions track. Now, one of the interesting things about Google Cloud Platform is that it was largely built out of the same internal infrastructure that we created here at Google for our own products. Now, in order to be more effective and efficient for a company, we've custom designed a lot of the infrastructure that backs the products that we're talking about. Now, this means that when your app integrates with our cloud services, it ultimately runs on the same servers that power everything from YouTube to Google Search.
And here at Google, we are very proud of our data centers. This year, Google reached 100% renewable energy for both our data centers and our offices.
Nice.
So this has been a huge focus for Google, as it was one of the first corporations to create long-term, large-scale contracts to buy renewable energy directly. And today, we're actually the world's largest corporate buyer of renewable power, with commitments reaching 2.6 gigawatts of wind and solar energy.
That's a lot of gigawatts.
That's a lot of.
Now, data centers are the backbone of the internet, processing and storing huge amounts of information. Our engineers have spent years perfecting Google's data centers, making them 50% more energy efficient than the industry average. But we still need a lot of energy to power the products and services that our users depend on. Now, that's why we began purchasing renewable energy, to reduce our carbon footprint and address climate change.
And when you build with Google Cloud Platform, you become a part of that. Your app runs on a completely green server in a completely green and intelligently designed data center as part of a green company. It's just a little something to feel good about.
Yeah, which is nice, right? It's not necessarily the first thing you're thinking about when you're building cloud services on our back-end infrastructure and our data centers. You kind of think of it as being out of your hand. So it's a nice little bonus to know that it really is. We think about that stuff for you.
Well, it's also a lot of small or medium-sized companies. They care a lot about things like this, but they don't have the flexibility or just the revenue to put their money where their passions lie. And knowing that they can use a service where they get those same benefits for free, it can help everyone really make sure that their company is a representation of their own value.
Absolutely. I mean, if you're in the situation where you're trying to be carbon neutral as a company, it's kind of hard to do that for yourself, right? It's like buying offsets, putting solar panels on your roof to run your office. Like, this isn't simple stuff that anyone can do. Yeah, exactly. So it's one of the benefits of being able to move to our cloud. Like, that's already taken care of. All of your processing infrastructure is already carbon neutral, thanks to the advantages.
We're going to make it easy. That's our whole goal. Make everything as easy for you, even the cherry on top Sunday stuff.
Exactly. Now I'd like to welcome back those of you who just learned about real-time insights. We just finished talking about how Google has reached 100% renewable energy for both its data centers and offices. Joanna, what is your favorite thing about our data centers?
Well, I've never been to one because they're really protected.
Yeah.
But I do think it's really cool how we use our own buildings to test our machine learning and AI algorithms.
Nice.
For example, our machine learning controlled AC systems notice that they can prevent server fires by cooling areas of the building in advance of large batch jobs instead of simply trying to cool active machines.
Wow.
And so that's really cool stuff that theoretically someone could have thought of, but having the computer program notice it that much faster made us more effective and better able to save money as a company.
Oh, fantastic. Yeah, I mean, it's really amazing some of the ways in which you can use these AI processes to improve things which aren't kind of obvious, right? And so being able to use that to analyze temperature trends within a large building and being able to figure out how can you modify the way that you're cooling things to not just be more efficient, but actually to reduce the possibility of fires in the data center. It's kind of amazing. It's time to welcome back the AI track. Welcome. We've been discussing the clever and green data centers that Google uses to power all of the Google Cloud products that we've been talking about today.
Exactly. And one of the great things about a large company is that we have the actual physical space with interesting enough needs to play with. And these kinds of experiments are what really let developers hone the algorithms that we offer to others. So I think we should go ahead and introduce the next sessions. What do you think?
Outstanding, yes. We've got 3 more wonderful sessions along the same tracks that we have been looking at today. For the big data track, there's the Zen Guide to Data Preparation for Analytics, hosted by Eric Anderson.
For AI, Zach Stone and John Barris will take you through accelerated machine learning in the cloud. And in industry solutions, Jen Bennett is back, and she's discussing the new age of manufacturing.